Hello everybody, welcome to this episode on statistics. In this video, we will be going through sampling distribution, standard error, and central limit theorem. Let's jump right into it. Sampling distribution. For you to understand what a sampling distribution is, I'm going to show you guys a quick simple example. Let's say you have a million of friends. I know this isn't a very normal scenario, but let's just go on with it for now. So you have a million friends, you ask each of them to roll a die, and their possible outcomes are between 1 and 6. And you're going to ask each of these friends to send you what number they got. And with all these numbers you got, so you got a million numbers now, you're going to plot a graph. So how is this graph going to look like? This is what the graph is going to look like. Before I continue, I just want to say that this is not a histogram. This is a bar graph. If you want to know the differences between histograms and bar graphs, please check out the video in the link in the description. I explained it very clearly there. So the number of people who got the number 1 in the die is around 16%. Number 2 in the die is around 16%, and so on. The same for the rest. And this makes sense because the possibility that you would get a 1 is the same as the possibility that you'd get every other number. So it makes sense. But now let's change things up a little bit. Let's say that instead of asking each of your friends to roll the die 1 time, you ask each of your friends to roll the die 50 times, and you ask him or her to find the average and send you that average. So now you have a million averages. But what do I mean by average? Let's say that I roll, just a quick side example here. Let's say I roll the die 3 times and these are my values, 6, 3, and 2. And now I divide it by 3 because I rolled it 3 times and I get the answer 3.6667. So this is my average right here. So in this case, this friend right here, one of your million of friends, is going to be doing this 50 times, and he's going to find the average and he's going to send it to you. So this is what the graph will look like if you collect all the data from the millions of friends. So the first thing you notice is that this value here is different because this graph is based on sample averages rather than individual outcomes. If a graph is based on sample averages rather than individual outcomes, it is called a sampling distribution. So I'm going to say it again, a sampling distribution is a graph based on sample averages rather than individual outcomes. So if you put these two side to side, key differences are the possible outcomes are different, the shape of the graph is different obviously, and one is based on the sample averages and this one's based on the individual outcomes. So just so you get a good grasp of what I'm saying here, I'm going to summarize quickly. A sampling distribution is a distribution or a statistic made from data of multiple samples from the same population. That's what sampling distribution is. Now let's move on to standard error. What is standard error? Okay, I'll get into that in a second. This is a population. This is an individual from the population. It doesn't matter what we're calculating. Let's just take the example weight of the people. This guy has a weight of X. And the average weight of this whole population is this symbol right here. This X is going to be different from this average of this. So how do we calculate the difference? How do we calculate the variability? We use the standard deviation. And that I also made a video on that. That's also going to be in the link in the description. But now, let's say that we're talking about samples. What are we going to use to find the variability between samples? For that, we're going to be using standard error. So what is standard error? Let's say that this is a line, like just a line, number line. And we're going to calculate the heights of people. These are the individuals. So some people are short, some people are tall. It doesn't matter which way. You just have to understand what I'm saying here. Some people are short, some people are tall. And this is the mean. There's always going to be a mean. Now you're going to find 4 other samples just like that. These are the individuals and this is the mean. So what a standard error is is basically taking one number line and putting all those means on this number line and finding the standard deviation of the means. That is the standard error. But here's where it gets a bit tricky. You can find the standard error of just this one sample. So instead of having 4 samples finding the mean and finding the standard deviation of the mean, you can directly find that standard error with just one sample using this formula. So what is n here? N is the size of the sample, and this symbol right here is the population standard deviation. Now the first thing that comes to your mind is population standard deviation. Why would I ever know the population standard deviation? You're right. That's a very valid point that you have there. The population, especially if you're calculating, for example, a whole country, like whole America, whole Germany, then you wouldn't know the population standard deviation, and instead you're going to be having to use the sample standard deviation. But if you're going to be using the sample standard deviation, you also have to use the margin of error. I'm going to discuss that in the next video. But what's important here is that if you use the sample standard deviation, it's going to be much less accurate than the population standard deviation. But I also want to say that there are going to be situations where you have the population standard deviation. For example, if you're calculating the marks of students in a class, then you will be having the population standard deviation. Since a class of 30 students, let's say, it's not that much, not that many students, assuming you have the time, that's the population standard deviation in that scenario. You can find the population standard deviation in that scenario. And size of the sample is how many individuals there are in that one sample you're trying to find the standard error of. Okay, we're going to be getting to central limit theorem in a sec. We're going to be having to learn the meanings of basic symbols. So x is usually used to represent the mean of all individuals. And the x with a line on top, I couldn't find the symbol for that, is used to represent the mean of all sample means. So for example, in a sampling distribution where it's graphed with sample means, the mean of all sample means is represented with the x and a line on top. Now here comes the central limit theorem. If x is a normal distribution, the mean, if it follows the normal distribution, then this x with a line on top 100% also follows the normal distribution. So you don't even have to think about it. It's not related to the central limit theorem anymore. It's 100% normal distribution. Don't even think of the central limit theorem. But if x is not following a normal distribution, then x with a line on top now is approximately a normal distribution if the sample size is big enough. This is where the central limit theorem comes in. If this x is not a normal distribution, that the central limit theorem suggests that x with a line on top, which is this mean of all sample means, it'll follow a normal distribution. It approximately follows a normal distribution if and only if the sample size is big enough. Everything else is the same. You can use, so what do you usually do with normal distributions? You compare it with the z distribution, and using the standardization, you convert the values in your normal distribution to z values, which is what I thought in another video. I'm going to be putting that in the description. But this formula for that standardization changes a little bit if you're going to be following the central limit theorem here. It's going to change from this, of course, with the line on top now. This is the original standardization formula. It's going to now be divided by n. Now, one question you might have is, n is sample size. So what sample size are we talking about? In a sampling distribution, we have multiple samples. So what sample size I'm talking about? Let's say that this is the normal distribution that you have, and there's a value over here, 22. You're trying to, and this only comes under the central limit theorem. So if you're following the central limit theorem, then you have to use this formula. Otherwise, you just use a normal standardization formula. So let's say that this is your normal distribution that you have after following the central limit theorem, and you want to standardize 22 into a z value. So I just want to say it one last time. These are the values of sample means. So one sample mean is 22. and you want to standardize it, and you want to know what the z value of it is. So you have to now implement this divided by n here. So how do you do that? So this n over here is basically the sample size of this sample mean right here. So this sample mean is 22. So what's the sample size of that? That's this 22. That's this n. It's the sample size of this sample mean, of this sample right here. The sample that has the mean of 22, it's asking for the sample size. So then you just put that in and follow the same standardization rules, and then you get the z value. Okay, and that's, for example, 50, yes. Okay guys, I'm going to end this video off here. In the next video, I'm going to be talking about hypothesis testing. I hope you guys enjoyed this video. I hope you've learned something. If you have any further questions, please put it down in the comments. If you think I can improve in some way, put that in the comments too. If you want to watch more statistics videos like this, check out my playlist on statistics and subscribe to my channel for future videos. See you guys in the next one.